Welcome to our Lappy video. We are going to take a look at how certain decision structures can help us streamline some of our programming. My block diagram just has the 4 outputs, the 4 tools, and a whole bunch of wires. So is there a more efficient way to make this program? Almost certainly. So in my block diagram, and I'm going to choose, let me scroll here. The first one I want to play with is the select operator, which works much like a switch. And if I turn on my context help just to see what it does, let me put this on the screen. So you can see that the select operator, takes a Boolean value in the middle. It has a true value and a false value, and it passes through to the output based on whether or not the switch is true or false. Okay, so if I was to wire up my plus here, and let me grab my minus as my false condition, now I need a Boolean, oops, something didn't take, let me rewire it, and then this will be my output. Now the quickest way to put in my Boolean control is right here to create a control. That's certainly a way to do it. I could also come to my front panel and find a Boolean control. I like this one personally for this because so I would name this operator, and top would be add and bottom would be, actually, you know what, I'll say very specifically x plus y or x minus y. Okay, so those will, okay. So with that said, I think I wired it all up here. Oh, I didn't wire it to my switch. I have to do that because I put it in on the front panel. That's right. And last step would be to test it. So I'm going to put in, let's see, 6 and 3. And something's broken. Oh, I have to take out the extra operators. Okay, so I'm going to hit the run continuously just to see what happens as so this is x minus y, my output's 3, x plus y, my output's 9. The problem here obviously is I can only do this once easily, and then I have a pretty nested switching algorithm to go through. So this is an option if I have 2 choices, for example, inches to centimeters. This would be a good way to switch between 2 unit systems. So that's possibility 1. Okay, so I'm going to go ahead and take all of this out. And let's do possibility 2. So now, this possibility is going to require a structure. So I'm going to come back to my functions, choose a structure, and I'm going to choose a case structure, and I will wire it around my first operator. Okay. Now, I can always move these nodes on the outside of the structure, and if I bring up my context help, what you will see is for a case structure, I can wire different cases of programming within, and I have input and output to the structure. This is my case selector, which is it true or false, and these are my inputs, and then I can wire this through to my output. Okay, and I have to give it a false, so let's say my true is add and my false is, you know what, I'm just going to go find a subtract here. And I guess I could have left in my Boolean. So live and learn, but we'll add a new Boolean. Again, this is for a 2 case. We can create a control, put it up here. Okay. And then I come to my front panel. And I'm just going to change which Boolean it is. I'm going to keep with the vertical slider, and we'll try this again. Once again, I have too many. So we run continuously, and I can toggle between addition and subtraction. Okay, so that's option 2, but there's a third option that works even better for more than 2 cases. So a case structure can have 2 cases. This is the gold star option. I'm going to go ahead and take out my operator, and this time I won't use it again. And I'm going to come to my front panel, and there are a couple of ways you can do this. I'm going to choose my favorite, and my favorite is under the modern ring in Enum is an Enum, enumerated list. So I'm going to say math operator here. I'm going to right click, and I'm going to go to properties. That is off your screen. So let me move it up just a little bit. So if you right click, oh, it's still off your screen. Right click, there it is. Now you can see the properties. Okay, so we're going to bring up properties, and I want to edit items, and now I can insert all my math operators. X plus y, x minus y. Now I could just say add, subtract, multiply, divide. The problem there is for my non-commutative functions, which one's first, right? Oops, I want to delete that one. I just want the 4. I'm going to click OK, and let me fix my program now. Stay on the screen. Okay, so now I'm going to come here, and I'm going to wire my blue math operator to my green selector, and the selector changes to blue, and my cases change. The last step here is I can make a case for every value in my enum or enumerated list. And when I pull this down, now I have divide, multiply, subtract, and add. So I kept those. I used cut and paste. I could certainly just grab those over here as well. In fact, that might be easier. I could also just replace, so this I said is divide. So I'm going to go to the numeric palette and change to a divide. I'm going to go to my next case, multiply. Again, I'm just going to replace through the numeric palette. I want this to be multiply, which means it wasn't even helpful to keep these, right? So here I'm going to put in a subtract, wire it up. And you'll notice this node on the output is still white, meaning there's a broken case. There's a case that doesn't have an output, and here it is. It's my last one. It's add. Okay, so now I come here and I run. 6 divided by 3 is 2. 6 plus 3 is 9. 6 minus 3 is 3. And 6 times 3 is 18. So that would be the more elegant solution to my problem. Finally, the last thing that I have neglected and that we should always include, this is the last minute, tops. So while loop with a stop button, draw it all the way around, look at that beautiful stop button, and now I don't have to use the run continuously. I can just run, click stop when I'm done, and I can still cycle through, change my values. Gorgeous. So that would be the elegant solution to that problem. Hopefully that gives you kind of an understanding of how structures work as you go through the structures. We'll take a look at some of these other structures, for loops, time structures, as the flat sequence even. As the semester progresses, formula node can be pretty helpful too. So feel free to poke around on your own and ask with questions either on the Brightspace page, by email, or in class.